So we got to reach back in our memory to Friday. We had started learning about inscribed angles on Friday. Inscribed angles mean that the vertex and the endpoints of the angle are on the circle. So looking here at problem number 6 up at the top of the page, they want us to find several different things here. First thing they want us to find is the measurement of angle C. Well, here's point C. So this would be angle C. What is the arc that angle C is intercepting? Yes, EB. Does anybody remember, and flip back to page 7 if you need to, does anybody remember the relationship between the inscribed angle and the arc that it intercepts? There is a relationship that we'll see that does make a right angle, but it's not always on an inscribed angle. There are specific ones, though, and we'll look at that today. It's 1/2 of the arc, yes. So the measurement of angle C is equal to half the measurement of arc EB. And how big is arc EB? 124 degrees. So angle C is half of 124 degrees. What is half of 124? 62. So angle C is 62 degrees. Fantastic. All right, now we want the measurement of angle D. Well, here's point D. So this is angle D. What arc is angle D intercepting? EB. It's intercepting the exact same arc. Angle C and angle D both intercept arc EB. Because they intercept the same arc, what's true about those two angles? They are congruent. Angle C is congruent to angle D. So how big is angle D then? 62 degrees, half of 124 degrees. Beautiful, beautiful. All right. I'm going to erase the markings that I have up here on my circle so that we can go and look at angle B next. Measurement of angle B. Here's angle B. What arc does angle B intercept? Not CDA, but just CD, because we're only looking at the crust. The arc is like the crust of the pizza. So just CD. Do we know how big arc CD is? So I can't use the same way I did angle C. Is there another angle that's intercepting that same arc? What other angle is intercepting the same arc? Yep, CED. This angle right here intercepts the same arc. I need to put that away. If they both intercept the same arc, what is true about those two angles? They are congruent. So we have angle B and angle E. Both intercept. Thank you. No, thank you. Arc CD. So angle B is congruent to angle E. Do we know how big angle E is? How big is angle E? How much? 19 degrees, right there. So if angles B and E are congruent, how big is angle B? 19 degrees. Angle E and angle B are congruent, just like angle C and angle D are congruent. Beautiful, beautiful, beautiful. All right. Let's go over to the right-hand column now and look at some of these arcs. The first arc they want me to find is EC. EC would be this arc right here. Do I have an inscribed angle that is intercepting that arc? Is there an inscribed angle that has its vertex back on the circle? Nope. When I look at the angle that is intercepting this arc, it's this angle right here. But that angle does not have its vertex, does not have its point on the edge of the circle. It would have to come all the way back like this to be an inscribed angle that's intercepting it. Okay, so I can't use that to find arc EC. Question. What would you call this chord right here, CB? It's a diameter. Why? Goes from one end to the other, straight through what special point? Radius. Doesn't go through a radius. A radius is another name of a different type of segment. Goes right through the center. The radius also touches the center, but the diameter goes from edge to edge on the circle through the center of the circle. And what does a diameter do to a circle? Cuts it in half. How big is half a circle? 180. So arc BEC would be 180 degrees. Now that we have that on there, do you guys see a way that I could find arc CE? Yes, we're going to do 180 minus 124. What is 180 minus 124? 56. So arc EC is 56 degrees. All right. Then we have arc CD. Here's arc CD. And we already said that angles E and B are intercepting that arc. If the angle is half of the arc, what would we have to do if we knew the angle to find the arc? Times it by 2. So 2 times the measurement of angle E is equal to the measurement of arc CD. So we would do 2 times what? 2 times 19 to get arc CD. What is 2 times 19? 38. All right. So I'm going to add that to the picture. This is 38. I should add the other one that we did too. This one back here was 56. All right. Arc DB. Well, if it's 180 degrees from B around to C this way, how many degrees is it to go from B around to C this way? 180, yes. So who sees what I can do to find arc BD?
180 minus 38.
Absolutely correct. 180 minus 38. What is 180 minus 38? 142. Right, so let's add that to the picture. This is 142 degrees right here. And then last but not least, we want arc ECD. So starting at E, around past C, and over here to D. What would I need to do to find that arc? ECD. ECD. Would you do 38 plus 55 and 180? Close, not 55, but 50, 56. Yep. So 56, arc EC, plus 38. We're not going to add the 180 because the 180 is half of the whole circle, and we don't have the full half. But you're absolutely right. We're going to do 56 plus 38. And 56 plus 38 gives us what? 94, yes. All right. Nice work jumping back in. All right, let's go down and look at numbers 7 and 8 now. Number 7 says find x and y. Well, let's see where we can find an x. Here's an x. X is part of angle R. And here's angle R. What arc is angle R intercepting? AB. Is there another angle that's intercepting that exact same arc? PR would be a segment. I'm sorry, what angle? What angle is intercepting that same arc? Yes, APB right here. So that means that angle P and angle R are congruent. They intercept the same arc. Angle P is congruent to angle R. Because they both intercept arc AB. So that means we would take the measurement of angle P and set it equal to the measurement of angle R. How big is angle P? 46 degrees. So I have 46 equals, how big is angle R? X plus 10. So to find x, we're going to subtract 10 from both sides. So how big is x? 36. All right, that's half of what they asked me to find on number 7. Now they want me to find y. So I'm going to erase some of my highlighting here. I'm going to leave those 2 congruence marks. But y is right here, part of angle B. Here's angle B. What is the arc that angle B is intercepting? PR. Right here. That's really hard to see. Let me try a brighter yellow. What other angle intercepts that exact same arc? Angle A. This angle right here also intercepts arc PR. So what does that mean about angles A and B? They are congruent. Angle A and angle B both intercept arc PR. So angle A is congruent to angle B, which means the measurement of angle A is equal to the measurement of angle B. What do we have for the measurement of angle A? 30. So 30 equals, what do we have for the measurement of angle B? Y plus 20. So then to solve this for y, we're going to minus 20 from both sides. And that means y is how big? Y is 10, yes. Nicely done, guys. Very nicely done. Let's look over here at number 8. It says find the measurement of angle PQR. P over to Q and down to R. This is the angle that we want the measurement of. What arc is that angle intercepting? It might be a right angle, I'm not sure. What would the name of the arc be that's being intercepted by PQR? Just this much? PSR. Right here, it's intercepting that whole thing. And we know that the angle is half of the arc. So the measurement of angle PQR is equal to half the measurement of arc PSR. Do we know how big arc PSR is? PS is 49 degrees. Do we know how big PSR is? No. We know part of it. We know this much. But we don't know this. But what do you notice around the outside of that circle? We know all the rest of the arcs except for that one. And I know that when we add all the arcs all the way around a circle, it adds up to how much? Adds up to 360. So I'm going to do 360 minus, and then I'm going to put all the other known arcs together. 49 degrees plus 86 degrees plus 105 degrees. So that would be 360 minus, what, 240, I think? Can somebody correct me if I'm wrong? I think it's 240. And what is 360 minus 240? 120. So from S around to R is 120 degrees. So what would you need to do then if you wanted arc PSR? Add them together, yes. So the measurement of angle PQR is equal to half, and now I'm going to add those two arcs together. We have 49 degrees plus 120 degrees. So the measurement of angle PQR is half of 169 degrees. What is half of 169? 80 what? 84.5, thank you. 84.5 degrees. Very nicely done.
So why do we add 120 because
We needed arc, or we were trying to find angle PQR. We said that that was half of angle PSR. Well, here's PS, that's 49. Here's SR, that's 120. So if I want PSR, I have to put PS and SR together. All right. Let's look down below. Inscribed polygon. An inscribed polygon is where I have all of the vertices of the polygon on the circle. And I'm going to draw two special cases for us. Here's the first one. We're going to draw a triangle that is inscribed in a circle. Notice 1, 2, 3 vertices are on the circle. This side of the triangle right here has a very special name when I'm talking about the circle. This chord right here goes from edge to edge, but it also goes through what? Yeah, that's a diameter. It goes right through the center, so this is a diameter. What do diameters do to circles? Cut them in half. So the arc from here around to here would be how big? 180. And the angle that intercepts that arc, this would be the angle that's intercepting that arc, would be half of that. What is half of 180? Half of 180 is 90. So if I see a triangle inscribed inside of a circle, and one of the sides of that triangle is a diameter, goes through the center of the circle, that has to be a hypotenuse. And the angle across from it would have to be a right angle. That's what it says right down here at this first bullet point. An inscribed angle of a triangle, if it intercepts a diameter or a semicircle, same idea, then the angle is a right angle. And then we're going to draw a quadrilateral in this other circle over here. Inscribed because 1, 2, 3, 4. All 4 vertices are on the circle. When I have a quadrilateral, a 4-sided shape, right here, 4 sides. When I have a 4-sided shape inscribed in a circle, the opposite angles are supplementary. So this angle here and this angle here, for example. Opposite angles are supplementary. Bless you. Yes. If it was the top and the bottom angles that I'm pointing to, those would also be supplementary. Any type of quadrilateral inscribed in a circle will have opposite angles that add to 180. All right, let's try this in a couple problems. Number 9, part A. What kind of a shape do I have drawn inside the circle? What kind of a shape in number 9, part A is drawn inside the circle? A triangle. And what would we call chord KM? That's a diameter. Which angle is intercepting that diameter? Angle L is intercepting that diameter. Because it's intercepting a diameter, how big is angle L? 90, yes. So they wanted us to find the measurement of angle K. I know that the 3 angles inside of a triangle add up to how much? 180. So the measurement of angle K plus the measurement of angle L plus the measurement of angle M equals 180. Angle K is 5x minus 4. Angle L is 90. And angle M is 8x minus 10. Combine all those together and we get 180. All right, so let's combine our like terms. What do we get when we combine our x's? 13x, yep. And then we combine the things that don't have x's, the constants. I have a -4, a positive 90, and a negative 10. We should get 76. So 13x plus 76 equals 180. Then we subtract 76 from both sides. What is 180 minus 76? 104. 13x equals 104. And then we divide both sides by 13. What do we get for x?
8.
X is 8. That isn't what they asked me to find in this problem, but I needed x in order to solve this problem. They wanted me to find the measurement of angle K. And the measurement of angle K, according to the picture, is 5x minus 4. So we do 5 times 8 minus 4. So the measurement of angle K would be, 40 minus 4, or 36 degrees. All right, let's go look at part B. Basically, same kind of problem. Do I have a diameter in example B?
No.
Yes. What is the diameter?
TV.
TV, because it goes right through the center. Since that's my diameter, what angle is intercepting that diameter? Which angle is intercepting this diameter? It is going to be a right angle, but I want to know which angle. Which angle is my right angle? Not V. That's one of the ends of my diameter. UT would be a segment. UTP. UTP would be this angle right here. Is that intercepting my diameter? Which angle is intercepting the diameter? UT is a segment. UVT, I'm sorry, I didn't hear that. UVT would be this angle right here. Is that intercepting my diameter?
No.
So which angle is intercepting the diameter?
Which angle is intersecting the
Which one?
TUV?
TUV, yes. Or we could just call this angle U. So that means that angle U has to be a right angle because it is intercepting my diameter. So then the measurement of angle T plus the measurement of angle U plus the measurement of angle V equals 180. Angle T is 7x minus 5. Angle U, that's my right angle, my 90-degree angle. And angle V is 2x minus 4. Add all those things together, and that equals 180. So then we combine our like terms. I have 7x and 2x that combine to give me what? 9x. Then we combine -5, positive 90, and -4. I get 81, sorry. So 9x plus 81 equals 180. Subtract 81 from both sides. Yep, 9x equals 99, which means x is how big? X is how big? I'm sorry, I didn't hear. X is 11, yes. X is 11. So now we can find angle V. The measurement of angle V is 2x minus 4. So we do 2 times 22, or sorry, 2 times 11, and we get 22 minus 4. And what is 22 minus 4? 18, yes. So the measurement of angle U is 18 degrees. All right. Let's look down at number 10. Number 10, I have what kind of a shape in my circle? Triangle. Is there a diameter in this picture?
Yes.
What's the diameter?
AB.
AB is my diameter. What is the angle that is intercepting that diameter?
C.
ACB or just C. Either one of those would be fine. ACB or angle C. Since it's intercepting a diameter, it has to be what type of angle? Right angle. This has to be a right angle. That is the first thing they asked me. Find the measurement of angle C. Well, the measurement of angle C is 90 degrees. Then they want me to find the measurement of angle A and the measurement of arc AC. Well, I know that the measures of angles A plus B plus C have to add up to how much? Has to add to 180, yes. Angle A is x plus 12. Angle B is 5x. Angle C is 90. When I add all that together, I get 180. So now we combine the x's, x and 5x to get 6x, 90 and 12 to get 102. So 6x plus 102 equals 180. Then I subtract 102 from both sides. I get 6x equals 78. And then I divide both sides by 6, and what do we get for x? 13. Now that I know x is 13, I can find the measurement of angle A by doing x plus 12, which would be 13 plus 12. 25, yes. So angle A is 25 degrees. All right. We still need to find arc AC. Let's look at the picture. Arc AC would be this arc right here. What's the angle that's intercepting that arc? Yes. Angle B intercepts that arc. Arc AC is twice as big as the angle that is intercepting it. So 2 times the measurement of angle B is equal to arc AC. So the measurement of arc AC is equal to 2 times, and then 5x. So 5 times 13. What is 5 times 13? 65, and I have 2 times 65, which gives us what? 130. So arc AC is 130 degrees. All right, we found everything on number 10, part A. Let's go over to part B. Is there a diameter in the picture? FG is a diameter. What angle is intercepting that diameter? Angle H. So angle H would have to be a right angle. So the measurement of angle F plus the measurement of angle G plus the measurement of angle H is 180 degrees. Angle F is X plus the measurement of angle G, which is 3x minus 10, plus the measurement of angle H, which is 90, equals 180. So we combine our x's. I get 4x plus 80. When I combine all my like terms together, and then I subtract 80 from both sides, I get 4x equals 100. Divide both sides by 4, and x is how big? X is 25, yes. All right, that's the first thing they asked me to find. Now we want the measurement of angle G. Measurement of angle G is 3x minus 10. So 3 times 25 minus 10. What is 3 times 25? Minus 10? 65. So angle G is 65 degrees. And then we still need arc HG. Arc HG is this arc right here. What is the angle that's intercepting that arc? It's intercepted by angle F, yes. So arc HG, measurement of arc HG is equal to 2 times the measurement of angle F. How big is angle F? 25. So I have 2 times 25. What is 2 times 25? 50. So arc HG is 50 degrees. All right, we have one last problem to finish up, and we got to go really fast to get through it. All right, let's look down at number 11, down at the very bottom of the page. This time, do I have a triangle? I have a quadrilateral, yes. In a quadrilateral, opposite angles are supplementary. So angles A and C are supplementary. Angles B and D are supplementary. So to find x, we're going to say angle A plus angle C equals 180. Angle A is x minus 10. Angle C is 4x minus 20. And that's equal to 180. Then we combine our like terms, x and 4x, negative 10, negative 20. That gives me 5x minus 30 equals 180. We add 30 to both sides. So I get 5x equals 210, yep. And then we divide both sides by 5. We get that x is 42. Then I can do the same kind of thing to find y. Angle B plus angle D equals 180 degrees. Angle B is 2y minus 12. Angle D is y minus 6. And that's equal to 180. Combine my like terms, 2y and y, negative 12 and negative 6. I get 3y minus 18 equals 180. I add 18 to both sides. That gives me 3y equals 198. And then we divide both sides by 3. We get that y is 66. All right, 2 more things that we need to find, and then we are done. Measurement of angle C. How am I going to find the measurement of angle C? Yes. Measurement of angle C is 4x minus 20. So that would be 4 times 42 minus 20. So that would be 168 minus 20. So the measurement of angle C is 148 degrees. All right. We have one last thing, and that's arc BD. Now my question is, do we know which way we're supposed to go around the circle from B to D? No. I do know that angle C over here is 148 degrees. And I know that angles A and C are supplementary, so I can do 180 minus 148. What would that give me? How much? 32. So angle A is 32 degrees. If the arc has just 2 letters, then it is the minor arc. So the measurement of arc BD is equal to 2 times the measurement of angle A. And we just said that angle A was how big? 32. So I have 2 times 32, 64 degrees. Arc BD is 64 degrees. It could not be the other way around because it had to be a minor arc, had to be less than 180. Have a great rest of your day, guys. Homework number 4 is due tomorrow. Please let me know if you have any questions, and please make sure you have that homework finished up when you come into class.